So we would like to use trigonometric substitution to evaluate this integral. And if we talk about trigonometric substitution, since here we have a quantity in a square root, we would like to transform it like a square root free or radical free. So we have to get a complete square inside the square root sign. So this is our Pythagorean identity, and if we divide it by cosine square of theta, then this transforms to this identity wherever we have values of theta permissible, or if we do this, that move one to the other side, what do we get is that we get secant square theta minus 1. Now if we look at this here, then what we got is this. Actually, that's not the best way to write it anyways. So we got not tangent square, but x square plus 9. And what I was getting towards hurriedly is this, that this format suits it the best. But in order to get 1 plus tangent square theta, since we have a 9 here, it will be a good idea to substitute x equals 3 tangent theta in here. Okay, so what will happen now is that this will become 9 tangent square theta plus 9, and that will be 3, and then tangent square theta plus 1. Okay, and if we look at the way we constructed our inverse function, here we have secant square theta, but secant theta would be positive in this territory, so we got 3 secant theta. In here, by positive I meant non-negative. So this quantity transforms to 3 secant theta, and of course dx will become how much? Dx will become 3 secant square theta d theta, right? So let's start working with these values. So first thing I will do is that just clear the marker board. All right. So what we have here is that we are taking x as 3 tangent theta, all right, which gives us dx as 3 secant square theta. And then what happens is that we go further and we got this quantity equals how much? Just a moment. This quantity will equal right here, that is this x square will be square of 3 tangent theta, so that will become 9 tangent square theta. Okay, and then downstairs, as you saw in our handwriting before, this is going to become 3 secant theta, right? And dx, of course, here I forgot writing my d theta, so dx will become this quantity, right? That is 3 secant square theta d theta. So now 3's will cancel and secant theta will reduce this power of 2 to 1. Okay, and that will be, okay, so this here. And so what we will have is that we will first have simply 9 tangent square theta, and remember 3 is cancelled, and the power on secant theta, that reduced to 1. Okay, and then now we have to evaluate this integral. Now the trouble is this here, that the derivative of tangent theta is secant square theta. We cannot substitute it that way, and the derivative of secant theta is secant theta tangent theta. But if we do that, what will happen is we will have only tangent theta remaining here. So I think a good approach would be this. Let's just go ahead and use the identity that we had written just a short while ago. Remember what the identity was? the identity was that we can write the tangent square theta as secant square theta minus 1, right? So once we do that, let me just bring it over here. Okay, sorry. Okay, so I'll just bring it over here. So this changes to this integral, right? And I'm just going to bring this outside for convenience. Okay, all right. So here we go. So now let's see what we get from here. So moving further from here, we have see, in a hurry, I don't know, I'm just forgetting to type. All right, so we have secant cube theta minus secant theta. Okay, and then we got d theta here, right? Okay, good. So let's just work on this. So we will work on this as difference of two integrals, and this one, I don't know whether you remember or not, it's been a while. We can use integration by parts, so let's try doing that. Okay, and how would we use integration by parts in here? Of course, we will have to do some factoring. And for the factoring, what we have to do is this, that we shall extract a quantity that's easily integrable. And you know, secant square theta is very easily integrable for us because the antiderivative of secant square theta is how much? Simply tangent theta. So we got this here, and now we may use the integration by parts, and let me just quickly recall that for you. The antiderivative of u dv equals uv minus the antiderivative v du. So here, since this is more easily integrable than this one, and this is like more derivative friendly than this one, so we may choose this to be dv. So what we mean by that is that dv is secant square theta d theta. So v will be how much? The antiderivative here, and that will simply be tangent of theta, because the antiderivative of secant square theta is tangent of theta. So what we get here is this. So first let me make some room over here, okay? And then what we have, if we go in this manner, is that we shall have right here. So we get u, which is secant of theta, then v, and we found out that v is how much? Tangent of theta, right? And then we have the antiderivative, okay? Sorry, first we have a minus sign, then the antiderivative of secant square theta, rather v. So this is v, and remember v is tangent of theta, and then du. So u is secant theta, right? And what is the derivative of secant theta? That is secant theta tangent theta, okay? And I'm writing d theta then. So what we have then is this, that is, I'm just bringing it down here, and I should go ahead and erase the handwriting here, okay? So this is gone, okay? And then we have this secant cube theta, and then we have a d theta here. And now we will go with just like routine technique, very slowly. All right, so we have, what do we have here? Let's work on this as diligently as we can, and then, you know, see if it works out or doesn't work out. So we got this tangent square theta, secant theta, d theta. And at this time, the only choice that is coming to my mind is that use one of the identities that we had worked with before and change the tangent square theta to what? Secant square theta minus 1. Okay, so I'll just take the whole equation actually. So what I'm doing here is changing it to simply secant square theta minus 1. Okay, so what we have now is, if you notice, that this whole thing now becomes, we have secant theta tangent theta, and when you just go ahead and distribute, so first we shall have the antiderivative of secant theta, right? And it's just like my writing style at the moment, so forgive me for doing that, just don't get confused. Okay, and then negative negative together will become a positive. Okay, and then what we shall get is, we shall get how much? Simply here secant theta d theta, right? Okay, so in this case what we got is, if we move this quantity, which is identical to the quantity on the left or the quantity that we have to determine, then what will happen? This whole thing then becomes, 2 secant cube theta, and this has migrated to the left, and I'm ignoring c at the moment. Okay, equals right here, this quantity right here, and let me just scroll down. Okay, and then if we divide by 2, we get the integral. And how much is this integral? This integral is very familiar to us, right? That is, this is we have first of all we have a 1/2 here, and you know secant theta, the antiderivative is natural log of secant theta plus tangent theta, and then we have a 1/2 here. Okay, and so if we just bring our values back, where were we? We were here, right? So now we are highlighted, and then let me just carry what we have to downstairs here. So you know our transformed value has become this, and as you saw that this is the same as, okay, 9, and then let me just write it in the second line just to have you know enough enough space, and just repeating all that. Remember this, that this became secant cube theta. Okay, and it wouldn't take too long to write. Okay, cube theta, and then minus antiderivative of secant theta. All right, and don't forget the formalities of writing the symbols. Okay, and this is simply secant theta, right? And then what that will do is, so notice this, we have the values right here. That is, we got what we got here, that we got the value of the first part as this. Okay, and this would be what? Simply the same thing as this quantity, right? You know, antiderivative of secant theta is simply natural log of absolute value of secant theta plus tangent theta. And let me not forget the constant. Okay, so what we get now is that we shall get that. So we have this, and now if you combine these two, then what will happen? Negative 1/2, sorry, positive 1/2 minus 1 is negative 1/2. So this quantity becomes this, and then you have 9/2 outside, and inside the bracket what we have? We got just this secant theta tangent theta, and I shall remove this. Let's leave the constant as a constant. Okay, and remember this, your tangent theta is how much? Your x was 3 tangent theta, right? So if x is 3 tangent theta, then tangent theta is what? X over 3, right? Okay, so let's write these values down. That tangent theta is here x over 3, right? So let me change this here. Okay, so here I'm writing this before, if it's okay. All right, so this is x over 3. And what is secant theta? Remember this, that so remember that secant theta is square root of tangent square theta plus 1. So that will be, tangent theta was what? Tangent theta is x over 3. So that will be x square over 9 plus 1. And 1 can be written as 9 over 9. So that will become square root of x square plus 9 divided by 3. So we can fill these values out here. So what we have now here is that we got, square root of, square root of x square plus 9, divided by 3, and in here we have the same thing for secant theta, so I'll write it down. So right here, square root of x square plus 9 over 3, and here we have how much? Simply x over 3. Okay, so that's the final value. You can go ahead and do the cancellations if you would like. Okay, so what we have is that if we distribute this 9 over 2 inside, what we shall get is that we shall get x times square root of x square plus 9, and 3 times 3 will cancel that 9 in the numerator there, and then we will have minus, and then we get 9 over 2 because there's nothing there to cancel 9, right? And then we get simply this quantity, right? That is natural log of absolute value of that. So this is the final answer for this integral that we originally had. Okay, let me just ask the computer. The computer just didn't put the absolute value signs in here.